Hey guys, so I'm recording now for the YouTube people. I'm gonna start this class by getting you guys to try the two last questions in this section as a little warm up and a little review. I'll give you maybe 4 or 5 minutes to try these two questions, and then we'll look at the answers, and then we're going to move into the new section, section 21. All right. So, yeah, good luck. Let me know if you have any questions, and we'll look at the answers in about 4 or 5 minutes. Cool. Good morning, by the way. All right, let's see. Okay, so I got one. I know it's pretty early here, but I got one answer from asthma, 600 milliliters for the first one. That looks good. I'll just give you guys one more minute to finish up the second one. M is much harder than L, and then we'll look at the answers and move on to something new. Okay, good. Getting some answers there. Somebody just asked, well, not somebody, Asthma, you just asked me to scroll down a bit. Does that help? Can you see the full question now? No worries. I'll give another minute or two for number or letter M because I don't. This is M is probably the toughest one in the whole section. So I'll just give you guys another minute or two to finish off M. I know it's a little bit long now, but we'll see if anybody can get the answer, and then I'll put the answer up on the or I'll write the answer there for you. Okay, I think that's enough time, maybe, or hopefully, to try these questions. Number or letter M is challenging because there's, the regular problem where we're going to find out how many micrograms that this person needs in total, but then there's some conversion factors to figure out how many inhalers that they need. So it's a multi-step problem. But anyways, let's look at L. I'll go a little slow through L. So if anybody's still trying to finish M, they can let me know. Okay, so I have an answer for number or letter M. We'll check your answers in a minute. All right. I'm glad that you got an answer at least. Um, Again, for M, there's kind of two parts. There's the original part that we've been doing this whole section, where you're going to need to find the total dose or total amount. And then there's a little conversion where you need to figure out how many inhalers that this person needs. So M is tricky, but L is a good warm up. So am I recording? Yes. Okay. Let me just get the editor on here so I can write. So L, how many milliliters of aminophylline, I think I'm saying that right, maybe not, aminophylline injection containing 250 milligrams of this active medical ingredient. So how many milliliters of this injection containing 250 milligrams in each 10 milliliters, that's a really bad sentence, should be used in filling a medication order calling for 10 grams of this chemical aminophylline, or however you say it. Well, first things first is there are 10 milliliters. Like, again, this is worded so strange. So there are 10 milliliters of this chemical. Oh, and how is this worded? This is worded so weird. There's 10 millimeters of this chemical in 250 milligrams. And what I'm trying to do is to figure out how much would there be in 15 grams. So the medication order is calling for 15 grams of this. Now there's a problem with my ratio right away, is that I don't have the proper units. I need to change my grams to milligrams. So 10 milliliters is in 250 milligrams, and I want to find out how many milliliters is in 15 grams. This question is worded really poorly. So to the two students, I think it was Asma and Kalsum maybe in the chat who got this correct, applause, hands off, hats off to you guys, because this is a really poorly worded question. I promise you, if you ever saw something like this, it would be worded a little simpler. Now, the problem is I can't solve this ratio until I have 15 grams into milligrams. I could turn milligrams into grams, but I'm just going to, typically I take the bigger number and turn it into the smaller one. So there's 1,000 milligrams in 1 gram. So I would get 15,000 milligrams. So let's just save our time because we did this all yesterday. Let's just put that here. And let's solve for x. So 250x is 10 times 15,000, sorry. So x would be this number divided by 200, and we would get 600 milliliters. So this unit has to be milliliters. So how many milliliters of this injection would we need to fill the medication order for 15 grams? We would need 600 milliliters. Let me just check my calculation too to make sure I'm okay.
Sir?
Oh, I'm getting 750. Oh, sorry, 250. Is that what you were going to tell me?
Yes.
Yeah, there we go. Sorry, little typo there. Too many numbers going on in my head. Yeah, 600. If you're wondering why I changed that to 250, it was just because that was in the original question. Thank you for that. I caught myself this morning. Okay, so this one, M took me actually a minute to wrap my head around M. Now, guys, like between us, this is obviously not on the first assignment. This would be on the second assignment, but it will be, I promise you, it will be worded a lot easier than this. But so like L is not necessarily a good example because it's very confusing to read. M is a good practice problem because there's so much to it. This would almost be more like a bonus or something on a test because it's got so many little tiny extra steps with that question. So M is a good practice problem because if you can do M, you can do anything. All right. So let me read the question. This one is worded much better, and I'll look at the answers. I haven't seen the answer yet, so we'll do this together. Excuse me. So the maximum recommended dose of beclomethasone, I don't know if I'm saying that right, but I think I'm close. It's an aerosolized inhalant. So it's like, something somebody would take by inhaling it. It's 168 micrograms, and this is very, very, very important, administered twice daily. Okay, so first things first. This is a really good thing to start any of these problems with. What is one dose of the chemical? One dose, actually, I can write it like this. One dose is 168 micrograms, or if I said milligrams earlier, I apologize. I meant micrograms. And this dose is administered twice daily. I'll keep that in my mind, that this person is going to need this 2 times a day. So they're going to need 2 doses per day. I guess I could write. I'm not going to write that. Maybe I will. I don't think I'm going to need this, but I will write it down. But I don't think I'm going to need this conversion factor. Maybe I will. The commercial inhaler delivers 42 micrograms per inhalation. So this is really interesting. So this person's going to need to take multiple inhalations for 1 dose. This is where this question really gets set apart here. So one inhaler, not one inhaler. One inhaler would be the device. One inhalation. How do you spell inhalation? Inhalation. So every time the person takes one inhalation, they're only getting 42 micrograms. And each inhaler contains 200 inhalations. So one inhaler contains 200 inhalations. Oh my gosh. Sorry, I'm running out of room and I'm forgetting how to spell inhalations. You don't need to spell these words if you don't want to. Okay, we're pretty much ready to start. And don't worry, this will look a little easier in a minute. So first things first, I'm going to set up my initial ratio. Now think about this. How many inhalers does the person need? Well, think about the inhaler. It has 200 inhalations. There's 42 micrograms per inhalation. So we could easily find out how many micrograms each inhaler has. And I'm going to explain that part in a minute. But there's no point in starting any of this inhalation business until I figure out how many micrograms of this chemical the person will need over the 60 days. I mean, that's step number 1. And let me just explain that again. It's asking how many inhalers will this person need over 60 days. Well, sorry, I'm just going to make that look a little clearer. We need to know how much chemical they need. We know that this person is taking 168 micrograms 2 times a day. So I want to figure out how many micrograms will they need over 120 days. Over 60 days, sorry. So my first fraction, I know that 1 dose of this chemical is 168 days. 168. I got an email there that got distracted me. 1 dose is 168 micrograms. Okay. Now my question is for you, I want to figure out how many micrograms total this person needs. But my question for you guys is, sorry, I'm just going to get rid of that. Okay, there we go. How many doses total is this person going to take? How many total doses? What do I put on top of this fraction? What number? What do you guys think? Let me know in the chat. How many doses? Yeah, yes. Kalsum, perfect. 120. And you didn't seem sure about that. You put a question mark next to it, but that's right. Now, for anybody who's not sure, let me organize my notes here. I'm just going to put like a blue line here separating this. Where did Kalsum get the 120? Why is 120 doses going up here? Well, so this is our first step. This is the ratio we've been doing all unit. It's 1 dose over the amount in 1 dose is equal to the total doses over the amount of those doses. This is our kind of like original ratio. We've been doing this ratio for every question. So this is the first part. So for anybody wondering, where did 120 doses come from? Well, this inhaler needs to be used for 60 days. And I know that there's 2 doses per day. So if anybody is wondering where the doses come from, it's right here, 120 doses. That took a little calculation on calcium and my part. This, guys, again, I wouldn't give you a question this hard on, say, a test, but this is a good thinker question. Like, if you can do this, you can do anything. Okay, so let's solve for x. Now, remember what x is. X is going to be the total amount of micrograms that this person needs over the 60 days. Over the 120 doses, this person is going to need or inhale 20,160 micrograms. Okay, now we're almost done. This is the total amount that that person needs. Okay. Well, the challenging part left is we need to figure out, well, how many inhalers will that person need? Okay, let's pick purple for this. So how many inhalers will the person need? Well, I know that this person is going to need 20,160 micrograms. I know that each inhalation, so one inhalation, is equal to 42 micrograms. Okay, so how many inhalations are they going to do? Well, I divide it by 42, but I'm going to go one step further. I also know that one inhaler would have 200 inhalations. And I'm using these numbers here that I'm circling up top in purple, guys. So these cancel, and you'll get your answer as 2.4 inhalers. Now, that's not a real number. Or, I mean, that's not a real answer. You can't have 2.4 inhalers. So this is another interesting question where you have to think in real life. If you are a pharmacist or a pharmacy technician, and the patient needs 2.4 inhalers worth of chemical, how many inhalers are you going to give them? Are you going to give them 2 or 3? Again, your patient needs 2.4 inhalers of the chemical. Will you, and you know, they need it to live. Will you give them 2 or 3? Don't think about like the ethics of pharmaceuticals and overprescribing of drugs. Don't worry about that. Yeah. So as like Aisha and Zarina said, you're going to give them 3, maybe not 3 at once, but the patient, like, you know, I'm not saying you're going to hand them 3, but the patient will need 3 inhalers total. Sorry, that looks like my little my niece or nephew wrote that word. Sorry, hold on. I promise I do write better than this. I know some of you have had me for 3 semesters, and I'm still not used to writing on a computer screen. I do write nicely on a whiteboard, but anyways, I don't think I've written on a whiteboard in a long time. Anyways, to just explain that answer, guys, the patient will need 3 inhalers because they need 2.4 worth of chemical. If you only gave them 2, they're not getting all of the chemicals they need. And this is a thing that happens a lot with certain types of drugs. You might get not over prescribed, but there's a lot of people like my parents. They're 70 years old and they have medicine, like leftover bits of medicine that you know, are probably from the 80s, from when we were kids. You know, we only needed to take the medicine for, say, 2 weeks, but the way that the inhaler worked or the way that the ointment was, we had enough for 3 weeks. So there will be some left over here with this patient. But typically with an inhaler, there's no risk of, think of somebody with asthma, they're going to need these inhalers for the rest of their lives, maybe. So anyways, we don't need to get into the ethics of like pharmacy and over or under prescribing, but you are expected on a test in math to think about this logically and think of a real life situation. This person will need 3 inhalers to get that medicine. There will be some left over, but that's just the nature of chemicals or pharmaceuticals. Okay, that took a long time, but I think like we're doing perfect for time. We're not even near halfway through the semester. Eid is gonna kind of change a few things, but nothing that you guys need to worry about. But we're almost done chapter 2, and there's only 4 chapters. This is the biggest chapter, so this is such a delight to teach because I'm doing math 1700 right now, and it's crazy. I mean, we're doing 2 to 3 topics a day. It's so fast. With you guys, it's so nice and relaxed. So it's 10:30. What time do we finish with Ramadan? We finish 11:20. I won't go that long, don't worry. But let's look into the new topic, dosage based on weight. And then yeah, that'll be it. So it is possible. Let me just kind of read this. Oh, and sorry, one thing I'll mention before I do read that. Guys, I highly recommend you guys practice some of the questions we did not do. Okay? So just it's good to do as much of this as you can. All right, sorry. So it is possible to receive a dose for a particular drug dependent on the weight of the individual. I mean, a good example of this, and again, I'm not a pharmacist or anything, but a good example is children's medication versus adult. There might be a little bit more to the pharmacology of a child versus an adult, but I know for something as simple as like a Panadol or ibuprofen, typically you wouldn't give a child the extra strength dose. There's a children's dose which has less milligrams or micrograms of the chemical because a child is typically weighs much less than a human. So sometimes a drug is expressed or explained as a quantity of the drug per unit weight of the patient. And you know what this is like? And maybe this is a bit of a weird example, but this is almost like in chemistry when you guys learn about moles per liter. Okay, think about moles per liter. It's the amount of moles of the chemical per liter of solution. Well, drugs can be expressed as the amount of drug in micrograms or milligrams per the weight of the patient. Typically, in the Middle East or something, or Europe, we would deal with the patient's weight in kilograms. So a good example is I don't know how to say that, and I should. Diethylcarbamazine citrate citrate is sorry, that's a tough word to say, is 2 milligrams per kilogram of body weight. So if somebody weighed 100 kilograms, they would need 200 milligrams. If somebody weighed 50 kilograms, they would only need 100 milligrams. So this is actually really useful. So the doctor can weigh you, prescribe the medication, and on we go. This is actually pretty easy. And again, this just reminds me of in chemistry moles per liter or grams per mole, even like any of these factors in chemistry. So let's start with an easy one. I'll do a couple of examples here, and then you guys can, there's only 3 examples, and then we talk about surface area. Well, let me just do maybe 1 or 2 of these examples, and then I'll get you guys to practice one. Actually, hold on. Let me just see one thing. I wonder if the practice is down below the surface area section. No, not really. Okay, no. All right, sorry. Ignore me. I'm just kind of seeing, I'm trying to put this into order here. So I'll do maybe one or two of these examples and then you guys can try. So dosage based on weight. Example number 9. The daily dose of a drug is 12 micrograms per kilogram of body weight. So first things first, let's write that down. 12 micrograms per kilogram of body weight. Now you can also write that as 12 micrograms per kilogram. Okay. How many milligrams should be administered to a person who weighs 55 kilograms? This is just a sorry, not this number, but this question is just a conversion factor like we've been doing all along. So this person weighs 55 kilograms. I'm going to multiply it by 12 micrograms per 1 kilogram. 55 times 12, and we're done. That's it. Halas. Easy. 55 times 12 is 660. Oops. So this person needs 660 micrograms each day. Cool. Easy. Nothing to it. Ooh. Okay, I'm lazy today. I'm tired. It's Wednesday. I'm sure you guys are tired. I'm going to see if you guys can do examples number 10 and 11, but I will give you a hint about 10 and 11. This is a good question because if you were in Canada or the United States, a person would know their weight in pounds. This is a very strange for me as a Canadian. We obviously use the metric system, but growing up, I always knew my weight in pounds. So first things first, I'm going to tell you the conversion factor here. 1 kilogram is equal to about equal to, it's not perfect, so roughly equal to 2.2 pounds. Okay, so I'm going to leave this here, and I want you guys using this information, using this conversion factor. I would like you guys to try these two. I'll scroll down a little bit, and I'll come back with the answers. So good luck. Let me know if you have any questions. Yeah, Judy, I'm not talking. I'm getting you guys to try or asking you guys to try examples 10 and 11. And sorry, and about that, I will give you guys one more minute to do this. And then I don't have any answers yet. Does anybody have any answers for 10 or 11? If you don't, that's not a big deal. And after this, I'll do one more topic. All right. So let me know if you guys have examples or sorry, answers for 10 and 11. And then I'll show you these answers and we will move on. Okay, let's look at the. Oh, sorry. Actually, let me hit. Did I pause my recording? No, I didn't. Okay, let's look at the answers here. I didn't get any in the chat. Maybe you guys are tired. It's Wednesday. It's Ramadan. Who knows? But let's look at these together. These are pretty easy in my opinion, but I'm a bit biased, I guess. I do have answers. So I'm getting different answers here. So let's check it out. Let's see what we get. Okay, so the dose of a drug is 0.25 milligrams per kilogram. How many milligrams should be administered to a man weighing 175 pounds? Well, we can't do this question until let me move my microphone, until we figure out how much this man weighs in kilograms. So 175 pounds, I'm going to change that to kilograms. This is just a rough calculation. You like, it's not nice like the metric system. So this is just a rough example of his weight. So, oops, I did that wrong. Oh, we got a nice number though, but I did it wrong. 175 divided by 2.2 gives us 79 point. Let's just keep one decimal place, 5 kilograms. Okay, now I can do this question. 79.5 kilograms, and this person needs 0.25 milligrams per kilogram of their body weight. So I'm going to multiply this by 0.25 and I'll get my answer. I think Kalsum said this, I think 19.88, or you could say 19.9, or you could just say 20 milligrams. Cool. Let me check the chat. So Lorena and Kalsum, yes. So asthma, I'm not sure where 318 came from. Oh, actually, I might have an idea. 79.5 times 4. Yeah, you for asthma in the chat, if you got 318, I think that means you flipped this ratio. You divided by 0.25 instead of multiplied by 0.25. The reason we're multiplying by 0.25 is so that the kilograms cancel. Perfect. All right. That's a very common mistake. And if that was a multiple choice question, 318 would be an answer. So, or would be what we call as teachers, a distractor. I don't know if you guys ever heard of that before, but when you're given a multiple choice, there's usually 4 answers. One is real. The other 3 are called distractors, and they're meant to be distracting. They're supposed to be what we would say plausible, but only one is the true answer. And I think that's why students don't like multiple choice, because every answer seems right, but there's only one correct one. Okay, Number 11, we're almost done for today. I'm going to show you number 11, then I'm going to explain how to do this. This is going to be hard because I need a ruler and I'm from home and I don't have a ruler. But anyways, we'll worry about that in a minute. Let's look at number 11. The usual dose of chlorobacil, I don't know, is 150 micrograms per kilogram. I feel like part of my friend, I think I told you guys this before, like my best friend, we started university the same day, and he studied to be a chemist, or sorry, a pharmacist, and I studied to do chemistry. But we lived together for about a year. He was my roommate for a little bit, and I swear some of his courses must have been how to pronounce these chemicals. So chlorambucil, maybe. Anyways, so the usual dose of this is 150 micrograms per kilogram of a body weight once a day. These questions could be made a little harder, but anyways, I didn't make the notes. How many milligrams? Oh, this is a little harder. Milligrams should be given to a person weighing 154 pounds. Okay, well, first things first, let's figure out what this person weighs in kilograms. So, 1 kilogram is equal to 2.2 pounds. We could actually do all of this in one big step, by the way. Dimensional analysis or unit conversion we could do this in one big giant step. But anyways, let's do it step by step. So this person weighs 70 kilograms. Okay, so I'm going to do the next part in one step here. So this person weighs 70 kilograms. They are going to they're going to need 150 micrograms for every kilogram. So that's easy. But I need milligrams, not micrograms. Okay, now the question is, how many milligrams are in a microgram? And to that, we can go back to my D2L little cheat sheet here. Let me check the chat before I do that. I got 70 kilograms, and people are saying and somebody just said, I don't know if this is correct or not, but well, Kalsum says 70, which I think is, we're talking about the kilograms. Asma says 70 milligrams, or is that the final answer? I don't think it is. But the person would weigh 70 kilograms. Okay, so the next step, we got to figure out how to convert from milligrams to micrograms. Okay, thank you, Kalsum. Yeah, so 70 is the weight. Now, let me show you how to do this. And I showed you this yesterday, but I'll show you again today. Let me just open up your math course. I'll share my screen here, new share. So to do that conversion, if you're not sure how to convert from milligrams, micrograms to milligrams, you can use this little chart here. Okay, so we are trying to go from micro. Let me get my pen here. Remember, this will be given to you, this little table here. So we're trying to go from micro to milli. That is 1, 2, 3 decimal places to the left. In order to do that, we're going 3 decimal places to the left. So this means that 1 microgram is equal to 10 to the negative 3 milligrams. Okay, we're going back 3 decimal places, 1, 2, 3. So 1 microgram is 10 to the negative 3 milligrams. So let's solve this. Let me go back to my notes, share my screen. Oop, I gotta clear my writing. Well, let's do this. Okay, I want to turn that off. There we go. So 10 to the negative 3 milligrams is equal to 1 microgram, and I can solve this question. Honestly, guys, you could just get the answers in micrograms and move the decimal 3 places to the left, whatever you want to do. I'm totally okay with you guys solving this however you want to. I shouldn't say solving this, but doing the unit conversion any way you guys want to. So 70 times 150 times 10 to the power of negative 3. And we
Sir,
get,
you forgot to share your screen.
sorry. I do that all the time. As anybody in my chemistry would know, I do, every time I switch to like the data book, I always forgot to switch back. But anyways, so I put this in here, the micrograms cancel, and I end up getting, let me try that again. So 70 times 150 is 10,500 micrograms, and this would be 10.5 milligrams. Now, again, you could have gotten this and just move the decimal place 1, 2, 3 places back to get this. Okay, you don't need to show me that if you don't want to. If you just like moving the decimal places, that's fine as well. All right, we're almost done. Let me just check the chat. Thank you, Kalsum. Thank you, Asma, for telling me about my screen as well. Okay, cool. So this is actually pretty straightforward, these questions. I mean, this is just unit conversions, basically. Okay, and don't worry about the bottom there. Right, this is a pretty straightforward question. Okay. So last part. Now, I'm not going to get to this today. And actually, hold on 1 second. I think I know where I can get a ruler. Just give me 1 second. Okay, so why do I need a ruler for this next part? Well, this is interesting. So dosage based on body surface area. Dosing based on body surface area is, now this is, something you guys might know more about than I do. It's common in cancer patients receiving chemotherapy, as well as children, pediatric or, young patients. They might do dosage not necessarily based on the weight of a person, but on their body surface area. Now, the body surface area is a calculation or a number that's done from the height and the weight of the individual. So it's done or completed using a called a nonogram. I think it's a nomogram. It's kind of like it's not a formula, but it's a chart we can use to determine the surface area of a person very roughly. Okay, the body surface area. I'm going to show you how to do this, but the body surface area is calculated by joining the height and the weight with the patient with a straight line on the nomogram, and reading it from the intersection with the appropriate column. This sounds crazy. It's super straightforward. And I wonder if using a computer, I can actually make this easier on myself. Okay, so there's a couple things I'll mention here with this question. And I will show you how it's done. It is a lot easier than it looks. But one thing I want to mention is to watch out. And if you look at the answer key, this is there as well. Watch out for the height in feet. Okay. We'll talk a little bit about this tomorrow, but if I said somebody was 32 inches tall, this chart is given as feet and then inches. Okay. So like, watch out with feet. I'm going to write this on the bottom. This is in the answer key as well, but it's very important. Careful with feet and inches, because 32 inches, for example, you would so there's 12 feet in an inch. Okay, so some of you guys might be tempted to take 32 and divide it by 12, and you would get I'm going to erase this, but if you did 32 divided by 12, you would get 2.67 feet. This is not correct. 32 inches would be 2 feet, so 24 feet, or 24 inches, 2 feet, and 8 inches tall. This is why the American or the imperial system is so bad. If I gave you 32 meters, you could easily change that to kilometers or millimeters. We wouldn't have to do anything too crazy with that. But be careful with feet and inches. If I said somebody was 32 inches tall, well, they're 2 feet. Or well, I guess a child could be 32 inches for sure. So they would be 2 feet and 8 inches tall, not 2.67 feet. It doesn't work like that, and that's part of the reason why I prefer metric. Okay, so let's just pick an example and I'll show you how this works. How do we figure out the surface area of a body? Let's make up a fake person. I'll use roughly myself as an example. I don't actually know what I weigh in pounds anymore. I'm a little bit afraid after a year of quarantining and COVID, not quarantine, sorry, but a year of the COVID stuff. But I'm about 5'6", 5'7". Let's pretend I'm 5'7" here. I think if you actually measured me, I might be closer to 5'6", but let's just say that I'm 5'7". So guys, look here. All right, this is, I'm putting a dot at 5'7", so 5 feet 7 inches. So I'm about 170 centimeters. Let's say that. Again, as a Canadian, we typically use feet and inches. I know that that's so strange, but we still have some remnants of our American friends. Now, weight in kilograms, or actually, and again, I know my weight in pounds, and I definitely know my weight before I got here. But let's just say I am, well, actually, guys, I think I'm heavier than this, but I think I am almost 180, 170. It's actually kind of interesting. If I was 170 centimeters tall and 170 pounds or 70 something kilograms. Well, let's do that. Why not? So just imagine this is a total fake person. I'm probably not 170 pounds, but imagine a person that is 170 centimeters and 170 pounds. I know I'm converting units there, or like I'm using metric and imperial, but you could say that I was, 77 kilograms. Doesn't matter. And what I do is I connect these dots with a line. Now, my question is, can I make a line? I can. I connect these dots with a line. Look at that. Oh, man. I love using a computer. So I connect these dots with a line. Now, this would be hard for you guys on a computer. This is obviously an estimate. This is not, doesn't need to be perfect. But my surface area, whoops, sorry. My surface area, my BSA, would be around, I mean, if I really zoomed in, let's just keep, 1.87 roughly. This is the surface area in square meters. So meters squared. Okay, right in here. Doesn't need to be perfect. A lot of you guys are going to be using your computer screens for this. What you could do, and I guess there's no point in showing you my camera, but I could take a piece of paper and put this on my computer screen to get the same answer. So you don't need to be perfect for this. Okay, I'm going to clear all my drawings and we're done basically for today, guys. But I just want to show you one more example. Okay, I'm going to get rid of that. Boop, clear all that. Let me check the chat before I move on. Loa, let me do another one for you. So one thing I'll mention, guys, is that the body's surface area in square meters is different for a child. So if you have an adult or a child, you'll use different graphs. The child one is a lot cleaner looking, isn't it? Like the numbers are a little better. Okay, so there's Aisha and Loa have mentioned in the chat they're confused. Let's do one practice. Sorry, guys. And then tomorrow, we'll look at this a little bit more in detail. And what I'll do is I'll show you an example. Like I'll do example 12A with you, and then I'll leave that with you for you guys to kind of try maybe tonight or tomorrow. I know you have an assignment, and then you can, we'll look at more answers tomorrow. So I'll show you one, I'll let it kind of sink in for the night, and then we'll practice more tomorrow. So example 12. Use a nonogram to determine the body surface area for an adult measuring 165 centimeters and weighing 65 kilograms. Okay, so let me write this down on a piece of paper. 165 centimeters and 65 kilograms. All right, so let's go back up to our chart. Now, guys, one thing that's really important, this is an adult. This means because it's an adult, we're going to use the adult graph, this graph right here. Okay, so I'm just going to put a dot on 165 centimeters. So let me zoom in here. Okay, so 165 centimeters, there's a dot. And I'm going to put a dot on 65 kilograms. Okay, do you guys see that? Let me pick a different color here. Let's go back to red or maybe bright yellow. So 165 centimeters and 65 kilograms. Okay, and now what I do is I draw a line that connects those two dots. So you would use, like a ruler or something to connect these two dots. And where they intersect, hold on now, got red. Let's not pick red, actually, let's go with blue. Where they intersect is the body surface area. So the BSA for this person is about 1.70 meters squared. The units are square meters or meters squared. So for the people who say that doesn't make sense, is that a little clearer now? I guess it was Aisha and Lola. Does that make a little more sense? Or do you want me to show you one more? Yeah, Lola's okay. Aisha, how about you? Yep. Okay, cool. All right. Now, I'm done. We've done enough for today. One thing I'll mention just before I finish, and you guys probably have another class later or something. First, I want to get rid of that line. Go away. Go away, line. There we go. One thing I want to mention, if you do B, use the child graph. So 10 kilograms and 24 inches. Oh, this graph's a little different. I don't like how the units are on the top. So 10 kilograms. This kid is 24 inches, which is 2 feet. 24 inches is 2 feet. So you could connect these. Obviously, that's not a nice line, but you would connect these and you'd get your answer. I'm not going to do this one. I'll leave this. But for question B, you would use the child chart. And you would make sure you converted from inches to feet. We'll talk more about this tomorrow. I think I'm done and think this is enough for today. So guys, if you have any questions, let me know. I'm going to hit stop record. We'll look more at this tomorrow, which is Thursday. So we're almost at the weekend. And yeah, any questions, let me know. Other than that, have a great day.